This topic is not uniquely, but at the top of the list of problems that we have in managing, positioning, and mapping data in the industry. Probably we see misapplication of convergence more times in terms of problems we have than almost any other problem. So I think it's important to talk about it. It's the one I chose first because I thought that it would have the most impact if people understood it better. I think in the context of mapping science, there are probably two key places for managing these things internationally, particularly. That these two things need to be managed properly in the United States as well. But people get very used to doing that because they work a lot in the United States. But if you're going overseas, they apply just as much. And they're more difficult because they're not familiar. But those two things are what projections are being used and how they're being used and why they're being used in a given country. And the second thing is, what is the underlying reference system that a particular country is using? In context of the second one of those, the geodetic datum is what it's called, or the geodetic frame of reference, is what defines where the origin of our measurements come from. And knowing that is very, very important. And it can be very important for a variety of different people. Probably the other aspect of that is it's not only about knowing it, but it's knowing about how to apply it. And this knowledge should be known really across the spectrum of a company. People in management should be aware of it. People in project planning should be aware of it. In fact, every project should have a defined criteria for who gets to choose that and how it is promulgated to people. And it should be on the wall or on somebody's computer, a reminder of this every time people go to a new phase of a project. Because if you get it wrong, then all your data are going to be muddled up. And things are going to be in the wrong place. You're going to drill a well in the wrong place. You're going to misunderstand the characteristic of the layers of geological strata that you're going to drill through. You're going to misunderstand pore pressure. You're going to misunderstand all sorts of things. You're going to misunderstand where your actual well is or where your development wells need to go. You're going to misunderstand how to do your modeling because you're not applying the information that you know, which is where things are. And those things, if they're mispositioned, then you're going to have a problem. Call someone who does understand what might have happened. And there are many folks now in the industry who have done studies of how to do this. Different companies have different groups sometimes of people that manage this underlying reference system or systems and the process or how you calculate those. There are key databases that tell you the constants and parameters for those systems. The real difficulty is that over a period of time, and when multiple people are involved, those what we call metadata, which is data about the data, which is the things like the reference systems, the projections, the datums, and so on. Those things are usually should be attached to the data that they refer to. So when somebody puts something in a database, it doesn't just get the data. I can get a list of latitude, longitudes, and heights. But if it doesn't tell me what datum it is, I don't know where the origin of those data are. And a different datum would put the same point with a different set of numbers describing it. It doesn't mean the point moved. It means that the datum changed. If we don't capture those information in our databases, and we'll be looking at multiple databases for a serious project offshore, Angola or Azerbaijan or wherever we're working, Malaysia. If we don't have anything describing for a particular data set what its original reference system is, then it's not going to match other data if you guess one. If you guess what it is, you may be right, but you have an equal opportunity of being wrong, and then it won't match the other data. And since we're pulling data through the E&P cycle from probably 20, 30, 40, 50 different databases in different departments for different types of technology, all of them have one thing in common. That is the location of the physical objects that allow you to map that information or correlate that information with other data. If you get that wrong, then you're going to get wrong answers. And you're going to spend money on things that you shouldn't be spending money on, which is mistakes.